To take a look at the difference between raster and vector, I've created a data set for the greater Blue Lake area. I actually took the city polygons from Humboldt County and extracted the ones for Blue Lake and then dissolved them together and then clipped the county parcel, road, and hydrant layers. So you can see the roads in black, the parcels yellow with a gray outline, and then of course the hydrants in red. Now, so when we want to convert raster to vector, in this case I'm going to go from vector to raster, there's a whole bunch of tools that we can use. Let's go to tools and search for polygon to raster. And that will take us to our polygon to raster tool, the input feature in this case being parcels. The value field is really interesting. I'm going to pick the land use and show you what Esri does with that. And I'm going to go ahead and save that. Oh look, I've already done a bunch. I'll just do this one again. So I'll put that in a new image file. Note that I'm giving it the Imagine image file extension. Don't worry too much about cell assignment type or priority field for now. This data is NAD 27 feet, I believe. Let's go ahead and check that just to make sure. So we are working in, yep, California State Plane feet. So that's okay. I mean, normally we project it, but for this example, I'm going to leave it as that. So then my cell size is 30 feet. And this is really important, as you're about to see. The cell size is what determines the resolution of our data, and boom, here's our data coming out. And if we turn off the parcels, we can see that data. Now, this is raster data. Notice that it's pixelated or has jaggies, as we'll call them, okay? And I did this at 30 feet, and for just the town of Blue Lake, that was probably too low a resolution, okay? Let's take a look at our properties. And you can see raster information. Whoop. There's our 30 by 30 pixel size. We need to look at spatial reference to know the linear units are feet. 30 by 30, we got 30 by 30 feet. So that's definitely too coarse of a resolution. So let's go ahead and run it again. And I'm going to run it at 3 feet or about a meter. Changing my file name here to 3 feet. We'll run it again. And oh, much nicer. I'll turn off our other layers here. And take a look. Now we have something that looks, much more reasonable. And we can see over here that we've got our different categories of timber production. We've got our, let's see, city areas. Public is what it's taking the roads to be. I guess that makes sense. Okay. But, notice that it's very different. Partly because when we were in our parcel layer with the attributes, there's a whole rich set of attributes we could put here. Okay? When we go to a raster, you're only going to get one column of attributes. Now, in reality, what's happening is that your raster has numbers in it. It has values in it. And normally that's what we're working with. So like with DEMS, temperature, precipitation, we're working with measurements. We're not working with categorical data. But every once in a while, this is really handy, that Esri will attach an attribute table. But again, because there's only one value in the image, you can only have one attribute associated with it. Still, pretty cool feature. You'll use it when we do work like this with land cover. Okay. However, remember the issue with resolution. That's a big one, because notice the resolution determines how fine your detail is in your raster, and it also determines your file size. So you want high resolution for the detail, but you want to be careful with the file sizes. I'm just doing Blue Lake here, but if I was doing this for the county of Humboldt, it would take quite a while, and that 1 meter data set would be pretty big. Now, normally if we go vector to raster, we're going to be using non-polygon data. But I'm going to show you what happens with roads. Okay, this is our road vector data set. Let's go back to our toolbox. Whoops, not there. There. And now we want to do polyline to raster. Okay. And let's go ahead and take our roads layer. And notice it still has a value field. I'm just going to use, oh wait, what did I do? Oh, I dragged the wrong one. Okay, let's try and drag the right one in. That'll help. Okay, for some reason it doesn't want to change that. Okay, we'll go ahead and we will figure out what it is we want to do. Let's take a look at the attribute table for our roads. And functional, that's what we want. Okay, so we'll go to functional. And let's go ahead and do that as our roads raster. We'll go ahead and do one at 30 feet here. So I want to show you what happens. I'm going to change my cell size to 30. Run that. And it works fine. I'm going to turn off my parcels so it's easier to see. And there's my road layer, which is really interesting because I ran it before and it was mis-georeferenced and I don't know why. So I'm not exactly sure what happened, but keep an eye out for that. Now, here you've got your roads, and one question is, why would we do this? Okay, we might. Okay, but usually when we convert something to roads, we wouldn't just convert it like this, partly because look at how bad this is, right? It's got a lot of jaggies in it. It's kind of strange. So we wouldn't do this very often. More often, if you're going to do something like a linear network like this, and you're going to convert it to a raster, you're going to do something like cost distance. Then you can get a raster where each pixel represents the distance from a road, or from a stream, or from anything else, which is important in looking at habitat, right? Some species like being near roads, some species don't like being near roads. So it can be good for that, but usually we don't just convert polyline to pixels, and certainly we'd use a higher resolution. The same thing is true for point to raster. Okay, there are some places where this is used, but it's pretty rare. I'm just going to throw in the type and do it as my hydrants, and I'll do it again at 30 feet. And you don't have to worry too much about these other settings unless you're doing something very specific with a point layer. I'm just going to show you what shows up. So there's our hydrants. Now, one of the important things to know is that, there's our hydrants. And remember that this is not going to exactly keep the point that our hydrant was at, because this point is much higher accuracy than a 30-meter pixel. Because a smaller pixel would be better, but it'll still shift it. In fact, if we then took our raster and converted it back to points, it would look like our hydrants had walked a bit. And it changes with each one. It's effectively quantizing the locations of the hydrant. So this is another issue to remember about when you're converting between vector to raster. Now, when you convert from raster to vector, you have a different set of issues. And usually when we do that, we're converting rasters to polygons as we did with the watershed. There it will follow every single pixel exactly. So again, we're more dependent on the quality of the image to the raster than we are to the vector data. Vector data is very good at maintaining very high accuracy, but it doesn't have this uniform grid of pixels laid over the landscape like a raster does. So that's the basic difference. And you can convert back and forth pretty easily. Just careful with the settings, especially the resolution.